Today we are going to talk about the linear regression and ridge regression in Python programming language. I know you all have a very brief idea about linear regression. What is linear regression? Linear regression is basically when x increases or our independent variable increases, our dependent variable also increases. This type of relationship can be represented by linear regression. We can actually give it a equation. Suppose in case of simple linear regression, we can give it a equation that is y equals to mx plus c, where m is the slope and c is the intercept, y is the dependent variable and x is the independent variable. In case of multiple linear regression model, we may write it as y equals to m1 x1 plus m2 x2 plus m3 x3 plus c, or any other terms, I mean any other variables. In case of econometric sampling, or in case of econometric modeling, we may write it as y equals to alpha plus beta x plus ui, that is the error term. Okay. So I know you all have a very brief idea about the simple linear regression model or multiple linear regression model. But what is ridge regression? For knowing ridge regression, we have to understand overfitting at first. Overfitting is basically there are models, and if the model is basically very much, I mean, slope of the model. The slope of the model is very high. If the slope of the model is very high, that means m in the equation of y equals to mx plus c. If the value of m is very high, then that is overfitting of the model. To reduce the overfitting of the model, we basically apply this procedure of ridge regression, which actually reduces the slope of the model or slope of the equation, and actually reduces the overfitting. Okay, so that is the application of ridge regression. At first, we are going to do simple regression with this model, and then we are going to do ridge regression with this model. So for at first, the first procedure or first step of our procedure is importing libraries. So we have imported two libraries here. Import pandas as PD. PD is basically alias, an alias for the pandas, and import numpy as NP. NP is also an alias for the numpy. In the second step, we are going to import dataset. Now our dataset is student record.csv, which I have uploaded, which I have installed. Let me show you the dataset. Um, this is the students record dataset, and let me open it so you can get a brief idea about this dataset. We have some columns: hours studied. Then the second column is previous course in the exam. Third column tells us about the extracurriculum activities, and the fourth column tells us the sleep hours. And the sample questions are in the fifth column, and in the sixth columns is the performance index. So the performance index is going to be our dependent variable, and all the other variables is going to be our independent variables. Here, let me say you something about the Excel also. As you can see, all the numbers are assigned on the right side of the box, but all the strings or the yes, no, all of these are basically assigned on the left side of the box. That means as they are words, so they are going to be stored as on the left side of the box. Now, if I want to regress performance index on all the other variables, I mean, I want to take the performance index as a dependent variable, and all the other variables like hours studied, previous course, extracurricular activities, sleep hours, sample question papers practiced by the students as our independent variables. So all of these five variables will be our independent variables, and and this performance index will be our dependent variable, and we are going to perform a regression on this. Okay. Well, this extracurricular activity, this column is basically having yes, no. We have to convert it into 1 or 0 as binary values. For that, we will do that operation later. But without doing this, we can't offer, or we can't actually operate with this data set. So let's begin. Okay. So as I have imported my data set, and for importing the CSV file, it was a CSV file, and for importing the CSV file, I will operate with read CSV code, and after giving read underscore CSV, I have to give the name of my data set under the first bracket, then dot CSV. Dot CSV will be obviously in the name of the data set, and PD is the alias for the pandas here, so we have to give the alias for the pandas dot read CSV, which is the code for reading CSV file, and then we have to give the name of the file or name of the dataset. So that's how you import the dataset. And next part, if I want to see the first 5 rows of the dataset and all the columns of the dataset, then the option is df.head. Df is basically this dataset. After reading the dataset is being stored in the df. Okay, so then if I want to see the first 5 column of the first 5 row and all the columns of the dataset or df, then I have to just assign df.head. Okay, now in the next part, if I want to check that whether there are any values in the data frame which is having zero values, I mean suppose this sleep hours, suppose a sleep hours, a sample question paper practice, that whether any of the student is present in the data set who hasn't practiced any sample question papers. That means in this column the value of that student will be 0. Suppose the first student or the student in the first index haven't practiced any sample question papers, so here the value will be 0. Okay, so I want to check whether there are any kind of values are there in which any of the column, it can be from any column, our study year, it can be from previous course that a student got 0 in the previous course, whether there are any values which are not present in the dataset or 0 values are present in the dataset. So for that, I will just give the name of the data frame, then dot is null. It is a code that we check or that we use to check whether there are any null values present in the dataset or not. Then first bracket open and close, then dot sum, first bracket open and close. So by this means I can actually get whether there are any null values present in the dataset or not. As you can see, there are no null values present in the any of the columns. What will be our next target? Our next target will be converting dummies into 1 or 0. As you can see here that this column extracurricular activities, it has 0, it has yes or no. Now these are binary. I mean these are supposed to be converted into binary values. Yes or no are not supposed to be um, accepted here. So at first I will take the extracurricular activities from the data frame. For that I am assigning data frame and within third bracket the name of the column, that is extracurricular activities. Then I am going to operate it as type category. Then I am going to operate that column extracurricular activity within the I am taking it from the data frame, so I am just giving data frame and within the third bracket I am giving extracurricular activities. Then I am just giving dot as type category. That means it will be assigned as category. Okay, so this column will be assigned in category, and after assigning in category, I have to just assign it the codes. That is called dot cat dot codes. That means 0 or on will be given to the column extracurricular categories or extracurricular activities. In that column, 0 or 1 values will be given, as you can see here also. After assigning the column as S type category and then assigning dot cat dot codes, we will get the value of 1 and 0, 1, 1, 0 in the category. Now let us define that which variables are going to be our independent variable and which variables are going to be our which variable is going to be our dependent variable. So our independent variable will be all of these columns, right? All of these columns are going to be our independent variable except performance index. So we are dropping the performance index from the data frame and we are assigning or storing it to the X. So you are taking df data frame, that is the actual data frame, and then you are dropping the column called performance index from it. And if I want to see this, I mean, yeah, it is okay. And what will be our dependent variable? That will be the performance index. Okay, so performance index is going to be our dependent variable, and we are just giving it the name, I mean the column performance index from the data frame, and we are storing it on the variable y. Okay, now if I want to for running linear regression or for running any regression, linear regression or ridge regression or lasso regression, whatever you want to pursue, you have to know that you have to divide your data set into two parts. One is training set and another one is testing set. Okay. So at first I am going to import train test split, and this train test split will be imported from scalearn model selection. From scalearn dot model selection, I will basically import train test split, and I will basically apply this train test split method here, and I will pass the name of the variables independent and dependent, x and y, and my test size will be 0.3. 0.3 is the test size. Okay, and random state will be 0. Random state will be 0 means my values will be not randomized. That means the sample values or the values of the training and test set will not be randomized, and will not be randomized means that uh, I mean the samples will not be randomized and then picked. It will not be randomized. It will be picked from a certain position, and it will not be converted or it will not be randomized again and again for picking different values. Okay. And what does it this test size 0.3 means? Let me write it here also. Let me point out this. It means that 30% of the record, sorry, it means 30% of the record of data frame goes to the test set. Remaining 70% goes to the training set. And this train test split, after doing this train test split by x and y, that is our dependent variable and independent variables, and the test size is 0.3 and random state equals to 0, we are going to get four values: x train, x test, y train, y test. If we want to see all these values, this is our training set, and our training set is going to have 70% of the data frame, 70% values of the data frame. If you want to see the first five rows of the test set, then you have to just assign x test head. And if you want to see the first five rows of the y test or y train, then you have to similar way, you have to just give y train dot head and y test dot head. Okay. Now this y test dot head, this is very important. This y test dot head is, I mean, this y test. This y test is basically the set of y. I mean, this set of y or this y test set is referring to the actual values of y. Now we want to check that um, actual values against to the predicted values. For that we want to predict the model, and for that we have to imply linear regression. For implying linear regression, we will take the linear regression code, and for that we have to at first import linear regression, and it will be imported from sklearn.linear model. This was also imported from SK Linear. As you can see, our train test split was imported from sklearn.model selection, and this our linear regression is imported from scale dot model. Okay, so this scale linear is very important here. Sklearn dot linear. Now we are assigning linear regression to L, so that we don't have to write linear regression in all the lines of the code. And then we are just applying L. L is nothing but linear regression. So we are applying this linear regression by saying L dot fit x train and y train. We will apply the linear regression only on the training set of x and y. Okay, and we are actually getting, we are going to get two things from this. When we are applying regression on x train and y train, we are going to get two things. One is obviously intercept, and another set will be of coefficients. So as it is a multiple regression, so coefficients will not be only one, it will be more than one. Okay, so I hope you all have a better idea about the multiple linear regression. So coefficients. will be stored. I mean, if I write it as L dot coefficient, then it is going to give me all the values of coefficient. And then if I want to store these values of coefficient into M, then I am going to give M dot L coefficient. Similarly, if I want to give L dot intercept, that is, we are getting the intercept through the linear regression model, and I am assigning those values into C. And if I print M, then you can see we have the coefficients, value of coefficients here, and we have the value of intercept if I print C here. Okay. So similarly, if I want to test the prediction results now, okay. So for testing the prediction results, I mean predicting the test set results, we will basically we are going to apply the X test. What is X test? As you can see, X test is the test set of the independent variables, and this was X test, right? This was X test, and this was the test set of the independent variables. Now we are going to apply the Y on the basis of X test set of X. So let me write it here. We are going to predict the Y with respect to, or on the basis of test set of X, that is X test. So we are going to apply, or we are going to predict Y with respect to, or on the basis of X set, or 10 test set of X. And we are going to print Y pred. As you can see, we have multiple values present here, so Y are being predicted. Now, as you can see from here, I am going to the next part later. At first, let me go to the actual values of Y. As I have said here also in the earlier portion, that you can see that this Y test is our actual values of Y, right? So what is the actual values of Y? In the 9394, 898, 98, all of these are index of the values. I mean index of the row. You can also say it index of the row, just like this. Okay, 9394898 and all that. So in the 9394 index, the value of Y, or the actual value of Y, was 53. Let me write it so that it can be much more clear. In 9394 index, the value of Y, value of, I mean it is the actual value, so I am supposed to write actual value of Y is 53. Now let me see what is the predicted value of Y in 9394 column. As you can see, it is showing that the value is showing that it is 50. Okay, so there is a significant difference, but the difference is not a very big difference. This is basically the predicted values of Y. So you can check between the predicted values and the actual values from this. Now, as you can see, uh, so the here, I mean, I have done that also earlier here. I mean, in the later portion, I have also covered that aspect. So let me predict, suppose let me predict Y for 799 1 9 and 1. What is 799 1 9 and 1? These are nothing but the values of, these are nothing but the values of the first row. 799 1 9 and 1. Okay, for these values, I want to um, predict the performance index, the value of the performance index, which was in actual, which was 91. Let me predict it. So as you can see, whenever I am predicting it here, L dot predict 799, 19 and 1. It is giving me a value of 91.888. So our model is basically looking good because the actual value was 91 and it is predicting 91.88368083. Now, if I want to see the testing set of the y, the first 5 rows, it is the testing set. And now if I want to see the prediction set or predicted set of y for the first 5 values, then you don't have to apply dot head, you have to just give 0 to 5. As you can see, there is a difference. Obviously the first value in the actual this y test is the actual value of y. Let me write this. I have also written this in the earlier portion. This is actual value of y. Right, and this is the predicted values. These y values are the first 5 predicted values of y. So as you can see, first is 53 here. Actual first 53, actual predicted is 50. Actual second 50, actual predicted is 53. So actual third is 80, actual third predicted third is 78. So there is a difference, but the difference is sometime higher, sometime lower. So it is not being very much, I mean, higher. The difference is not going to be higher. It is sometimes it is greater, sometimes it is lower. So it is not going to be prevail. I mean, sometimes it's plus 2, sometimes it's minus 2. So ultimately there is no difference. Now, if I want to check the difference, for that I am going to create a new data frame, that is actual versus predicted data frame, and in that data frame I am going to apply PD, that is the alias of panda. PD dot data frame is the code that we use for create new data frame. Then we are going to assign the name of the columns. This actual value name of the column, predicted value name of the column, difference is the name of the column. These three are the name of the columns which are in the single quotation. In the actual value we are passing the values of y test set of y. In the predicted value we are passing the values of y pred, that is the predicted value of y. And in the difference we are going to just show the difference of y test minus y pred. And then if we run the first 5, I mean, if I want to see the first 5 the part of the data frame or first 5 rows of the data frame, then I have to give the name of the data frame, actual versus predicted df, and 0 to 5 I have to assign. As you can see, the first difference is 2.53, the second difference is minus 3, then the fourth and then the third is 1.72, fourth is minus 1.36. So the difference are being opted out. Sometimes it is a positive, 2 positive, sometimes it is 3 negative, sometimes it is 1 positive, sometimes it's 1 negative. So ultimately there will be a very less amount of difference that will be remaining in the model. Now if I want to know the r square, the value of r square, it is basically called here as r2 score. For knowing the value of r square, I have to import scalan dot matrix. From scalan dot matrix, I have to import R2's code. After importing R2's code, I will basically run the R2's code on y test and y predict. That is, y test is the actual value of y, and y prediction is the y test. Let me write it also. Y test is actual values of y, and y pred is nothing but it is the predicted values of y. So I am going to run the regression or run the R square test. I mean, I want to know the value of R square, and we are taking two sets. One is Y test and another one is Y pred. That is the predicted value of Y and actual value of Y. And R square is showing a significant value, that is 0.98. That means it is 90%. That means 98% variation of the dependent variable can be explained by the independent variables. That means performance index is 98% influenced by our studies and previous core extracurricular activities, sleep hours, sample questions, and paper practice. All of these are actually explaining the performance index by 98%. It is significantly great. I mean, significantly helpful, significantly beautiful. It is that this amount of variation can be explained. Here, if I want to run a scatter plot on this, I have to import matplotlib.pyplot as plt, and I am assigning the scatter on y test and y plate, that is the actual value versus predicted value. And if I run the scatter plot, as you can see, there is no scattering away of the values. If the values are close, it means it's a good result. You can see that predicted and actual values are close to each other. They are not scattering away from each other. So that means it's a good result. This model looks extremely fit. Okay. So it looks great that they are very close to each other, actual and predicted. If suppose one value is here, one predicted value is here, or one predicted value is here, and one is here, one is here, then it looks like then it's not a good result. Right, that means that predicteds are actually shifting away from the actual. Then it's not a good result. Okay, this model is obviously an extremely fit model. In the next part, we will see that if the model is extremely fit, then we can apply ridge regression to the model to reduce overfitting, as I have said in the beginning of the video also. So in the next part, we are going to apply ridge regression.